Application lifecycle management. So what does that entail? Well, as programmers, we're really just concerned with writing code, right? And that's pretty much all we've really done up to this point in this series is talk about how to write code because that's the main responsibility of a programmer is getting things done. And if you put yourself in the shoes of a project manager, their goal and kind of their main responsibility is keeping an application or a project on time and on budget. So they need to manage expectations, manage deadlines, and manage all that stuff. And how they do that is through what's called the software development cycle. And that just goes from the very beginning when somebody, whether it be a customer or a CEO or manager, somebody envisions an application or envisions, whatever they want, all the way to the end through supporting the application after it's been deployed. And we're in the middle somewhere as programmers. And I remember being a junior programmer, uh, and I had no idea the software development cycle even existed. And I think that's by design because, as a programmer, you're kind of the workhorse. And that's really all you should be focusing on is getting things done. You're handed technical specifications and you just program against them. So really you're the main workhorse when it comes to building the application. And so that's really what I focused on is I grew and did this stuff for years and years. Eventually I kind of broke out into the architect role and wore the hat as both an architect and a developer where you're exposed to a lot more of the software development cycle. You sit down with the users to gather the requirements and get an understanding. You write the technical specifications, the models. You play a part in developing the application, testing the application, and managing the application after it's been released. So, I can tell you when you start out, it's good to know this stuff ahead of time because and then you'll be able to talk the project manager lingo and help them manage their expectations and give better ideas of timelines and phases and scopes and all that stuff. So that's what we're going to focus on in this video. I just want to talk a little bit about the software development cycle as a whole. And you know what? Everybody does it differently. It's really all going to depend on who you're working for, the size of your team, your project manager, a lot of things. So I'm going to kind of give you the generic version because it's nice because this is kind of the cookie cutter version that applies to everything. So, if you're working for a big company that has a very strict, they follow everything by the book, they have their own phases and milestones and outputs at the end of every milestone, things like prototypes and stuff, this still applies to it. Or if you work for a small company, the project manager says, hey, I need this done in 2 weeks. Here's the specs. Go do it. I'll see you in 2 weeks. And it works for that too, because even if you don't follow a software development cycle strictly, you're still going through it. You just don't know that you're going through it. So we'll take a good look here at the software development cycle. All right, let's jump into the outline. That's what we're going to start off with here, software development cycle. And then we'll move into the testing overview. Talk a little bit about what is involved with testing an application. As programmers, we're really going to, our main focus in the software development cycle is going to be developing the application and testing the application. And some of these you do at the same time. You do testing while you develop it, right? Because you need to make sure that it works. So we're going to look at really the whole cycle, and then we'll look at testing as a whole here. All right, let's start it off here with a look at the software development cycle. So the cycle is really just the start to the finish line of an application. Again, when somebody envisions it all the way to the minute we deploy it and are kind of done with it, even though we're not really done with it because an application is never really over. It just starts over again. And that's what the software development cycle is, just our guide. It's kind of our map through developing an application. And as I said here, as programmers, we really sit down here where our big job comes in when it comes time to develop the application and test the application. These other phases, while they're there and they're important, are they're for people like business analysts, architects, and then support staff. So starting at the top, the very first step in the software development cycle is right here, requirements. And this is where the business analyst sits down with the clients or the users, whoever is requesting the system, to fully understand what it is they want. So this is where they're going to define the functional and non-functional requirements. Functional requirements are, what the system is, what's it going to do, all the what, where, and why kind of stuff. And then the non-functional stuff is, things like, what kind of a load is it going to have, how many users, it's all the stuff that doesn't entail the system. So things like load and performance, what are the performance requirements, what are the security requirements, all of those kind of requirements outside of the business requirements that the application is supposed to do. So this is the business analyst doing all this stuff, gathering all this information, and he's going to turn this information into something that the development team can understand. Because once you're through with requirements and he's passed off his version of the specs to the design team here, this is where the architect gets together, and maybe the developers as well, to get an understanding of the technical specs. And the output from the design here is the architect is going to create technical models, technical specifications, what are called use cases. I mean, this is where we can break out Visio, and if you've ever used Visio, and start diagramming this stuff out. Again, both non-functional and functional stuff. So we can, an architect will define exactly what components are going to be involved in the system, what services. If you're developing a web application, are we going to need to hook up to a web service? Where's the data going to come from? So it's going to find all the application boundaries, all the components, all the services, all the behaviors, and he's going to map them out. And also with the business analyst here, define the technical specifications. And these are the architect translating the business requirements into something that they can understand. After that, the third step in the development cycle here is developing. This is where we come into play, and as programmers, we're going to take what the architects and business analysts give us, which are going to be the technical specifications, and we're going to write code. We're going to write all the different layers of the system here, fill it out, and hopefully, we can build an application exactly to what the user wants and what the architects and business analysts expect us to write. So this is where it's important to, if you work in one of those, big company or big development team where you have technical specs, which most of them do, then it's gonna, you're gonna have to understand how to read technical specs. And they're pretty straightforward. They're standard programmer talk, so you'll be able to understand them just by understanding how to program. But I'll give you some examples here when we get into our nugget on how to read technical specifications, because we need to understand how to read things like use cases, maybe even UML diagrams or database diagrams, and just how to even create a prototype, because prototypes are a very good way of ensuring that everyone's on the same page, from clients to designers to us as developers. Prototypes can definitely save a lot of time. Even though you can spend a little bit of time creating them, you can really save a lot of time in the long run by ensuring that everyone's on the same page. So we'll take a good look at that here when we learn how to read technical specs. After that, the fourth stage here is testing the application. And this is where we refine our code, squash any other existing bugs that we didn't catch during the development phase. And this is also going to, again, depend on the type of company you work for, the people that you work for, because you may have a quality assurance department, QA department, that does a lot of the testing for you. And they're going to do what's called black box testing. And we're going to talk about this in testing. But essentially, that is, they are testing to make sure that the application meets all of the requirements and all of the features work as they were defined. And then we as developers will do white box testing, or what's called unit testing, where we'll test and retest the code here. And a lot of the white box testing you'll do during development stage, where you'll test units of code to make sure that they all work. But this is why also we have a little section here on testing, because as developers we're going to be responsible for a lot of the testing. So and there's a lot that goes into testing. There's a lot of different testing levels and testing methods, so we'll talk about those here coming up. And finally, here we have the manage phase. And the first part of the manage phase is going to be release management. How do we get this application to our users? So, if you're developing a Windows application, are you going to create a setup? Are they going to somehow get it over the internet or over the web? If they have a web application, are they going to have access to it internally, externally, all that kind of stuff. So release management is important, not only for delivery method, but also what if they encounter a bug? How are we going to fix it and then re-release and manage updates and things? But the majority of manage here and support is going to come down to supporting the application and giving the users the technical support they need when they need it, to answer their questions and to fix bugs and do all that kind of stuff. So what happens when we reach the finish line and we're done? Well, we'd probably put a version on it and then lock down the code and call it version 1.0, or if you have 1.0.0, depending on how detailed you want to track your version numbers here. So usually this is major, minor, build, and then there's even a revision on here as well. So 1.0.0.0. Although usually we just show this kind of stuff to the users, 1.0, show them major and minor release builds. And this really plays into the software development cycle, because once you get feature requests from users, depending on how many it is, if it's a total overhaul to the system, if it's just a minor bug fix, things like that, it's going to depend on which one of these numbers you increment. But you're going to start this process over again. You're going to start at 1, gather those feature requirements, design them out, develop them, test them, and you're going to do different forms of testing, things like regression testing to make sure your new functionality doesn't break your existing functionality. And then again, this is where the whole release and update management comes into play, and you'll do it from there. So that's the software development cycle. Again, it's an iterative cycle, and I didn't mean to get too detailed here on you with versioning and all that stuff. You really none of that stuff is going to be covered in the test. They just really want you to understand the phases, and that there's a requirements phase where we gather all the information from the user. There's a design phase where we map out the system and get technical specifications. The develop phase where we write the code, testing where we test the code, manage where we manage everything from deployment to supporting our users. And the cool thing about this software development cycle is it is very generic, because whether you work in a big company that follow these strictly and you always know where you are in the cycle, or whether you're just building a project at home by yourself, you're still going to go through all of them. So you're still going to find out what you're building, figure out how to build it, make sure it works, and then make sure it keeps working. So that's why this is just a great kind of generic way to keep track of where you are in the cycle. All right, let's zoom in here on testing and talk a little bit about what's involved with testing the application. Because as programmers here, most of our time is going to be developing and testing the application. And we've been looking at developing up to this point. Now let's focus on what it takes to test an application. And first here, let's just get familiar with some terminology here. I mentioned we have white box testing, and this is where we as programmers are going to test the internals, test the actual code line by line, unit by unit, to make sure that it functions properly, and we get returned, for instance, if we're testing components and classes, ensure that what's coming out of those classes is what we expect, and what's going into those classes is what the component expects. So we'll do things like API testing, and this is the application programming interface and how we communicate with our classes. We'll do all that kind of stuff, make sure that we can communicate with our classes. Code coverage. And this is where we create tests to make sure that we hit all the lines of code within our application to make sure there is no faulty code. And then you also have fault injection, which can just help improve the coverage of a test and test the code paths within our application. And then black box testing is, again, really what QA people will do, or anybody outside of ourselves testing the application, because they won't have access to the internal code. So what they're going to do is they're going to test based on the specification and the feature requirements, and just make sure that everything lines up with the requirements and the technical specs. Now we also have testing levels, and these levels are just kind of what kind of testing we're doing. For instance, as programmers, one of our big responsibility here is going to be unit testing, and this is where we test maybe a group of code, maybe a line of code, maybe a specific method or a group of methods, or class. It's really just we're testing a unit of code. And there's tools that are built in to Visual Studio called MS Test, for instance. MS Test is Microsoft's version of unit testing. And you can actually create a testing project in Visual Studio and then hook it up to your components and do what's called automated testing. So the cool thing about this is you'll save your projects, you'll save your testing projects. So in the future, when we get to regression testing, we'll talk about it. In the future, when you add features, you'll want to rerun these tests to make sure any new feature didn't break existing features. So that's why you can make projects out of these, save them, and then reuse them. It's also a great way to do automated testing in the future. And I just want to note that you cannot. This does not come with Visual Studio Express. All right, so you'll need to get a full version of Visual Studio in order to utilize and see MS Test in action. But it's really easy to use. I can tell you from experience. You just create a testing project, hook it up to your components, and let Visual Studio do the rest. People like this because it's integrated with Visual Studio. Another popular one that I've used and many developers use is NUnit. NUnit is outside. It's not a Microsoft product. It's a third-party product here, but it's awesome and it's great. And people like it because it's very easy to use and it doesn't clutter up inside of your Visual Studio work because it's separate. It's outside of Visual Studio. Hook it up to your components, and then you can do unit testing and create outside projects that test your components. So Google NUnit there if you want more information on that. You also have integration testing, and integration testing is how we can test portions of our application that kind of go outside of the boundaries. For instance, maybe you're working with a vendor who has a web service, and so anytime you change your application or make updates to it, you need to make sure that your application still functions with their stuff. And especially because you have no control over their environment, so they could change or update their web service at any time, and you need to make sure that your application adheres to their standards. So integration testing is just really just testing, the boundaries of your application. System testing is kind of testing the application as a whole. So all the components are in place, everything has been developed, and it's really just testing everything. Regression testing is, again, as I mentioned here, is a way to test existing functionality. And this is going to come into play when you add features in. So you add some kind of feature into your application, you need to make sure that that feature didn't break existing functionality. So this is where it's really nice to create these testing, when you create your unit testing projects, to make sure that they're stored in your solution, or if they're outside of Visual Studio, make sure that you know where they're at, because they're going to become very useful down the road when you add features in. You're going to want to rerun all of these tests to make sure that everything still works. And finally, here we have acceptance testing. And acceptance testing really just breaks out this here below, alpha and beta testing. Acceptance testing is just customer testing. This is where you hand it off to your customers. You go through a testing phase with them. The alpha phase of acceptance testing is really just a limited number of users or customers. Maybe it's their first time seeing the application, working with it. You'll generally only want to give it to a few people so you can work out any of the minor bugs that they may find before you take it into a full-blown beta test, which will be, not such an early look, but more of a refined version of the application. It's already gone through some user testing. Now we want to release it to the masses and make sure that everything functions as it did with this limited number of users, as it will with many users. So it's kind of our final test here before we release it to the masses. And finally, we have non-functional testing. We talked about what non-functional is. It's really just everything outside of the application itself. So things like performance testing. We want to make sure that the application performs right, and if it doesn't, how are we going to tackle it? Are we going to look at maybe improving code, or are we going to improve hardware? We also have stability testing, also known as load testing. How many users can we fit, or can use the application at the same time before you start to notice slowdown, or maybe it blows up, that kind of thing. We also have usability testing. How easy is it for the users to use? Is the interface easy to navigate? Are things in the right place? Is it intuitive enough? Or are we going to need to rearrange some things to make it a little easier to use? Things like switching between forms or web pages, is that easy to do? This is pretty important in my opinion, because if you've ever used bad software, poorly designed software, it's a nightmare. You don't ever want to use it again. So it's good to make software highly usable, because then people will like your software, they'll want to use it, especially if it looks nice. Things always have to look nice. So I'm a big believer in usability, because the nicer things look and the easier are to use, makes people's experience that much better. Security testing. This is really going to entail things like, if I'm working with sensitive data, if your application exposes any sort of sensitive data, then will it be easy for hackers to compromise the system? So they'll, if you are working with sensitive data, maybe you're pulling information from a database that has things like credit card numbers or passwords, things like that, then you want to make sure that stuff is encrypted. So that's what security testing will go through, just to make sure that everything is secure. And localization testing is really for, if you're developing an application that's going to need to support multiple languages, multiple concurrencies, and or currencies, I should say, and things like that. That's called localizing the application to the specific environment that it's in. So you can see there's a lot that goes into testing, and it is, it can be kind of daunting at first looking at all this stuff, but it's really going to depend on the type of application you're building, and you're not going to be responsible for all this stuff. You're really going to be responsible for unit testing. That's really the major role of the programmer when it comes to testing, is unit testing. So we just need to make sure that our code works well, and it meets the requirements of the users. Alright, so in this CBT Nugget, we took a look at the application lifecycle management. And really this was just a nugget on getting you familiar with the big picture here when it comes to developing an application. From the start, again, someone envisions the application, all the way to the finish line. When we're done, we're ready to release it to our users. And again, the exam here is going to just make sure that you understand what those phases of developing an application consist of. So just think requirements, design, development, testing, and support and maintenance. That's it. Those are the and obviously what each one of those entails. So once you get familiar with that and you kind of understand how the software development cycle works, it really fits into any environment, whether you're developing for a small company or building a project for yourself, or you're going to work for a huge company that has a very strict software development cycle. So once we got familiar with that here, we just took you through and got you familiar with some of the different areas of testing, really all the different terminology out there, the different testing methods we have, black box testing versus white box testing, and then we looked at all the different things you can do with testing, and we saw the main responsibility of us as developers and programmers is going to be unit testing. I hope this has been informative for you, and I thank you for viewing.